Hey guys, so welcome back. Well, today on the bench we've got a doozy. This is a General Electric. I believe it's a model 517F. I believe it's from about 1951. And I think this is a pretty cool looking unit. Unfortunately, it's in pretty bad shape. Cosmetically, the case is pretty bad. I'll go through that in a minute, but it's cracked. There's a piece missing out of it. It's missing 3 of the knobs here on the front. I can reorder these, but before I spend a bunch of money on this, I thought, let's see if it's even going to work. Otherwise, it might be just a parts set. It's got an interesting tuning system right here. It is a clock radio, AM only. It's a clock radio that I don't know if you're familiar, guys of my age know all about these things, but basically the on-off is located on the clock control. So the clock controls a switch that turns power on to the radio or not. It can also have a timer where you can, like you're going to go off to sleep, you'll turn it up to maybe as much as an hour, and that timer will run down, and then once it reaches the end, it'll shut the clock off. And then of course it's got an alarm function where you set the time for when you want it to turn on. So you can have it to where the radio comes on and you hear music playing. I don't know if this one does or not. The ones I've had, in my earlier years, it might buzz as well with the music playing. So we'll just have to get into it and see what we got on it. The clock, I have no idea if this thing works. I have not plugged this in, and you're going to find out why right now. Let's turn this thing around. So, I said this thing's kind of a basket case. So let's see what we have here. First of all, since it just moved on me, here you can see the broken case. Can we fix that? Mechanically we can fix this. Cosmetically, I don't think so. But it'd be interesting to see if we get that far with it. At any rate, you may have one that's not in this bad a shape, so we can go ahead and get into it, see what we got. Alright, so you can see why I didn't bother to plug the cord in. So I have no idea if this clock works. So as you can see, this is one of the first things we're going to have to deal with. Another thing I wanted to point out is I mentioned that when this clock turns on, not only does it turn on the radio, I'm going to zoom you in here. This is kind of unique. Okay, focus. Okay, so what this does is when the clock turns on, it applies power to this outlet. And you can plug an appliance into that outlet that it says is rated for 1100 watts. A coffee pot. So the idea is you put this maybe in your kitchen and set it for what time you want it, for it to turn on, so you can get up in the morning, you get the news playing, and your coffee's ready. Now, if you want to turn the radio off, but you still want the power going to your coffee pot to maybe keep it warm, you then flip that switch to turn the radio off. But that stays hot. So the whole time the radio, if you will, the clock motor has turned the unit on, there's power going to this. I don't know if we're going to keep it that way or not. That's kind of iffy. Here is where you change the alarm setting. You push that in and turn it. And I see in here we got this interesting type of tube setup. We'll just take a look. This section is missing off of here, as you can see. But I have a schematic, and we'll just get into it and see what we got. So let's go what we're going to work on today. So hang on, and we'll get into take a look at what we have inside, and then we'll see step by step if this thing will work. So we'll get back into that right now. Do we have an antenna? We do have an antenna. Alright. So you can see we have a loop antenna on the back. The good news is it's got plugs for disconnecting. What a wonderful thing. So let's see if we can get these to release, and they do. Yellow is on top, not that it matters. Okay. So there's the antenna back. So if you're missing this antenna back, maybe what we could do is take a look at what the windings look like so you can make your own. Later on in the video, what I'll do is I'll put up how many winds are on this, maybe give some general dimensions on it. So if you need to fabricate one of these for this unit, that'll help you out. I know they're never shown anywhere else, so that'll help you. There's no trimmer on this back panel, so it's just the racetrack. So I'll let you know what that is later on when I get around to it. Okay, I don't see any reason to keep this power line on here. Let me get it off of here. It's just in the way. And no, it was not a polarized plug, obviously. And it doesn't have any markings that somebody, well, there's a little bit of, is that paint? That might have been interesting to see if that went to the, that avoided the chassis. So I've lost that opportunity to see, but I guess so. So here's our tubes. So here's our tubes that are in here. I can see we're missing one straight away, the 35W4. That would be the rectifier, I believe. And so that tells you that probably the capacitors in here are so short that when they turned this on, it popped the filament, the bonding wire off of the 35W4. We'll see when we get in there. So we got 12AV6, 12BA6, 12BE6. These types of IF cans have tunable slugs. So yes, that means fixed capacitors, which means probably very likely silver mica dizzies in here. And then we got the tuning condenser is in there. That's good. And the clock is behind this. So why don't we get the rest of this out? Okay, we got 3 screws in the bottom. Take the knob off while I'm thinking about it. No set screw, just pulls off. Okay, let's see what happens. We know the clock is going to be attached. Looks like to me the tuning dial will just slide out with it. It does. Okay then. Well, good. We got enough wire attached for this. Boy, we got the bugs were living in here. My gosh. I've seen so many egg sacs in my life. The grill cloth is a little bit tired looking. Okay. So let's see what we have here. Some stress cracks on this. We have to be careful with this guy here. Let's see. So we turn this around. You look at the speaker. Kind of a first look, huh? We had a metal heat shield on the bottom. So let's see, as a witness mark, all this paint stuff was on the side opposite the speaker, facing up. So it was kind of like taped on to the bottom. Okay. All right, no peeking. Yeah, that speaker, gross. Yeah, the bugs have been loving this. Bug lover special. Just so we can all enjoy this, look at this together. Yeah. So that speaker's in pretty bad shape, obviously. I'm not going to try to repair that, I don't think. Audio output transformers also covered with bug cases. Good Lord. This thing has just been abused, huh? Okay, let's take a look on the underneath. All right. What do we got here? Okay, first question is do you think anybody's been in here? Maybe. It's not obvious, and I wouldn't say it's been recent. Let's see the rest of it here. Okay, you can see one lead comes over here to the switch to outlet. This one lead is where you get power going to the radio from here. We've got a couplet. Here's the local oscillator. Obviously the big electrolytic looks like a 2-section access to the cans underneath and above. Other than that, we've got 4 wax type capacitors. So the capacitor job on this isn't terribly bad. The resistors are all square shouldered, so they may be okay. We've got a little capacitor over here. We'll have to check, but it's in the oscillator section, so I'm assuming that's a mica down in there, so it'd probably be okay. I need to find which one's the audio output, and we'll be on that coupling capacitor straight away. These are interesting tube layouts, tube sockets. You see that the wires that go to the tube sockets disappear into holes in these phenolic plates. And then on the top side, I haven't ever worked on one of these, but I've seen them. Inside of here is how that connection is made to the pin connections somehow. And that in the manual they say you shouldn't need to get in here and open any of this. So we'll see. Alright, we'll check to see how our connections are. I need to dig up one of these rectifier tubes and then we'll see how this all works. Now I have a schematic on this guy here. Okay, so we don't have a transformer obviously, right? So we've got a series string set. Here's the series of the heaters and the rectifier. So here's where the power comes in. So here's where the power comes in. Here's the clock works. So when this thing's plugged in, the clock is running the whole time. Then when it makes a contact, there's a contactor shown here. It then provides power. The radio is isolated from that with that switch we saw in the back, but as you can see, the outlet gets power whenever this is connected. So when this is plugged in, the clock is going all the time. If the clock is on or the alarm is on or whatever, then this outlet is always powered. Then the radio is only on if all that's taking place and the switch is on. So you can't rely on noise from the radio to tell you if there's power going into here. Okay, you know there will be to this, but whether that's hot or not. All right, so you got to be a little bit careful. Alright, so then other than that, I think we just got an All-American 5 layout. You've got a converter, IF tube, detector audio, power output tube, and there's C20. That's going to be the one we need to check for the grid coupling capacitor. Make sure that's, probably just go ahead and change it. So it's going to go from pin 2 and 5 of the output tube coming from the plate of the detector, which is 7. Okay. Do I have any voltages on here? Okay, so here they've been kind to say, if you can see that, but this is the B plus bus, and this is the B minus plus bus. So here's our 2 filter capacitors that we were just looking at, the 2 section capacitor, and there's our audio output. Okay, so what do we want to do first? I guess what we'll do first is let's check to see if I have another 35W4. If not, I'll need to run to the store and get one. Okay, clean living. We've got a 35W4. I don't know if this one is from an earlier project, it was a pull or what, but if it was bad I wouldn't have put it back in here, so it's probably going to work well enough. Okay, so what I'm going to do is I'm just going to see if I can get some continuity through that string. Actually, I didn't need the rectifier for that, so let me just set it aside, put it back in the box. Alright, so we're just checking for ohms because I'll be getting resistance through the filament, so really don't want to just try continuity because it might be enough to not beep. Alright, so I'm getting 1 ohm, just these things 2 touching. It's nice to have good gear like this, right? There we go. Okay, so we want to go 3 on the 12AV6. Okay, 12AV6. 12AV6 is this one. Okay, through to pin 3 of the 50C5. Get anything? You guys let me know, because I can't see. Okay. No, nothing. Okay. Not a surprise. Now we'll see if we can work these things around and get something to come up. Nothing there. Okay, we're missing the rectifier, but that shouldn't be a problem, I don't think. Nothing happening there. Something happened there, didn't it? Okay, that one was having a bad connection. That was the, I believe this is the 12AV6. Nope, 12BA6. This one, the IF. Okay, we got it back. And then this last one. Okay, about 100 ohms. So we've got this series string back. Okay, so that's quick. It's usually a little rocking them around a little bit. I think what I want to do is disconnect the motor so that we can get it out of the circuit. I don't want to have to deal with it while I'm putting power to the set. So let me get in there and see about disconnecting the wires from the motor. Document which wires go where. One of the first things I was looking at is, so where's the capacitors that might make this a hot chassis or not. So there's a couple of them. We have a across the line capacitor right here. It shows as a 0.05. That capacitor is located right here. It's in as a 0.047. Okay, Royal Tiger. And then there's another one though. If we come up and we follow this line here and come here to B minus bus, you see there's a 0.05 here that goes to the chassis. So that one we need to be careful of for sure. I haven't found it yet, I haven't looked, but I know where this one is. So that one would put it like an across the line cap on. That could be a X. This one need to be a Y. 0.05. Could be this one. We'll have to see. But wherever that is, that's what we're going to do for it. Okay, so what you have is here's your two power lines in, right here. And so it'll probably be easier for me to pop the schematic up on the screen. But basically, this lead here that comes in, I believe is the top line that we have here. So let's follow this. Okay, it's going to come in and it's going to go to, it's going to come in and it's going to go to the plug and also a black line to the motor, which it does. So here's the line to the plug, and then this line right here, which is tied to the same point, comes over here and goes into the clock motor. Alright, so that carries it from here to here, and then from here we're going to go and we're going to hit that across the line cap. So that comes here, there's a small black line right here, black wire that comes through. It doesn't go to the switch, it comes back around to here and it's tied into the same socket as this side of this across the line cap, which is there. Okay, so that's where that line goes. Then it also continues in to the heater and the cathode, sorry, plate of the rectifier tube, and this is the rectifier socket right here. So that's where that one goes. Okay, so then the other line lead, if you will, coming in from the plug, okay, is here. And where is it going to go? Well, it wants to go to the yellow lead of the motor. And boy, it doesn't look like it does that, does it? It looks like it comes over here. So what it does is it comes up here to a socket on the audio output tube. This is not I think this is just a tie-in point here. Then there's a lead that comes over here that runs, and at first I thought it was going up here like this is a switch, but this isn't the switch. This is only the volume knob. The switch is in the motor. Okay, so it comes up to a point up here, and so what you're seeing is that comes over, it gets up to here and actually does go to one side of the volume control. Now from here there's a lead that then takes it down to let me see, where does it go? where does it go? Hang on. I found it a while ago. This lead here comes oh, wait a minute, that does not go, sorry, that does not go to the volume control. That goes behind the volume control and comes over here, and then that goes to the motor. Okay, that's the two black leads to the motor. That's nice because I was getting lost. Okay, so that goes to the motor. Now it comes back to the motor as yellow. So it comes back to the motor as yellow, hits the outlet, which it does, then it goes over to the switch, which it does, and the other side of the switch then goes on and ties in somehow to this side of the, so there's our double-sided capacitor of the cross the line capacitor. It must be here, it comes to here, ties in, and comes over to here, and then ties into this. Boy, that is some circuitous routing. So that's how the power line goes. So how do all those lines look? Now, they look okay, they look solid. This cord needs to be replaced. So what I'll do is cut these here and make some connections so I can use that to plug into the my power supply. I'm going to disconnect the motor and make that a completely different problem for now. Okay, so in order to do that, to disconnect the motor, I've got plenty of lead here, but I don't have any tie-in points, you know. That insulation back here is damaged, so I have to put some shrink on that. But it's almost cut all the way through. It may be cut. Well, we'll have to check. Okay, so let me get these two separated from each other, and then I'll bring it back. Okay, so I firmly believe that it doesn't matter which of these black leads goes to the motor. I think that it'll always turn the right direction. But you know, if I get in here troubleshooting it and something's not working right, I'll second guess myself later. Did it really make a difference? So just to save myself some angst, I put some tape on this. I didn't even really need to number it because one of them's white, the other one has no tape on it, and this one has tape on it, so I'll know which ones are which. Okay, I'm just going to go ahead and cut it. Alright, so we got that separated from the motor assembly, and we'll look at the motor as a separate question later on. It'll be interesting to see if it'll run, but I expect the lubricant inside to be all dried up, and if I do let it run, it might damage it, so I'll need to address that separately. Anyway, let me set that down out of harm's way. I wouldn't want this case to get broken, right? What I want is this one that goes here to tie on, goes to the motor, and then comes back through yellow. So I believe what that means is for the radio to work, I really can just put a plower on either side of that point right there, right here. So that's what I'm going to do. Because I'm just, in order to power this unit up, I'm going to get rid of this, and then I'll apply power to here and here, and that should be the same as applying it here and here, and that'll get power to the radio. Okay, that's what we're going to do. Okay, so those are cut off, they can stay cut off. They might get a little power to them, so I'm going to cover them up. Okay, now let's get rid of this. So let's get rid of this. It's just causing trouble here. I'm going to leave enough of a tag here so I'll know what went where. Boy, that just crumbled like crazy, man. This power cord is just atrocious. Look at this. It's just cracking. Okay. And it wants to come up here. So let me catch it right here. God. Okay. Okay. This. Yeah, my cord's no good. So what do you do? Let's get some power going to this. Let's see if we get anything out of it. Let's see. So I need to put the rectifier tube in. Okay. I'm going to make sure the radio switch is set to the on position. I just need to check the back plate. There we go. For the radio to be on, the switch needs to be to the right. And it is, okay. Alright, so I'm going to lay it like so. I have this on an isolation transformer, and I'm current limiting it. And get it to stand up. Let me get something rigged up where I can hold this position. I'll be right back. So I took the plug that was on the end of this, broke away all the rest of that bad insulation, and I'm going to create a way to bring my power in through that plug, backfeeding it into the plug, and that'll give me an easy way to connect up the power from the power supply. Because this plug here is good at keeping those two lines separate. So I've bent a little bit of a shape on this wire so that the heat shrink won't slip off. And that'll hold it tight down against the plug, so if the other one slips up, this one won't. Okay. That'll give me a way on the outside to plug in and provide power, so I don't have to do this and worry about it falling off and touching inside of here. So this will be the power we have coming in. I've got my panel over here that has a 1 amp fuse on it. I've got my variac, isolation transformer, dim bulb, and kilowatt over here on the left, and I'll just keep moving in front of you. I guess I need to move that over here one of these days. Okay, so let's get ready to turn this on. So I got this, I'll turn it down all the way. And what I'm going to do is bring the power up slow and watch the power and see if we get the dim bulb light up. Now maybe what I can do is get this to where you can see. What do you think? Y'all like that, don't you? Hang on. Okay, so we have the variac, we have the isolation transformer, we have a kilowatt, we have the dim bulb. The dim bulb is in the circuit and it's sitting here on top, and that is a, forgotten what I have in there. I think it's 100 watt. 150 watt bulb. Could be lower, but we'll just see. Okay, let's and we'll see the voltage here. So turn this all the way down. There is no power switch. I'm going in directly. I've got the volume turned all the way down. So we'll just see what happens. Alright, what do you want to start with? 20 volts. Dim bulb is in the circuit and it's not on. You know, let me give you guys a demonstration. Let's say that there's a short in here. Let's see if this will show up. Watch the light bulb. The voltage dropped away to nothing. Get a little more voltage. See the light bulb glowing? So that means if I have a short in here, that what happens is that light bulb turns on and it saves this circuit. It causes it to bypass whatever else is left, and the light bulb restricts the current quite a large amount, so it keeps it from burning up. So that's the purpose of the light bulb. It's not parallel like your light bulbs in your house would be, it's in series, so it does suppress the voltage depending on how much current's going to the radio. Okay, so we have almost 40 volts going. The bulb is not glowing. Look here to see how many amps are we pulling. About 90 milliamps. Okay, it's going up a little bit. In a minute I'm going to check to see if I have any tube glow. I don't see any glow right now. I may not have tube glow. Let's see. I may have something that needs to be rocked around. Well, the fact that I'm pulling some amperage tells me that I've got something glowing, because there's no transformer in here, so there shouldn't be any reactance of a transformer taking that power. So I'm at 110 milliamps, so I'm assuming something's going through the filaments. I'll turn the volume up just in case we'll hear something if something starts to crackle. You know, another thing I need to do is make sure I'm getting voltage through my my rigged up system here. So we'll be looking for AC voltage here. I hear buzzing. Can you hear buzzing? The radio is buzzing. So we know we have something. Here it comes. Can you hear it buzzing? Okay. So we're at 50 volts. That agrees with that, so we are getting stuff through. No glow on the bulb yet. I wonder if I can pick up anything yet. Don't have any antenna hooked up. A little more power. Once again, I'm on an isolation transformer, so that will prevent me from getting across the line. Depending on what I touch. But where I'm standing, I'm not completing a circuit. Okay, we're certainly not picking up anything right now. We probably don't have enough voltage in to get the tubes to conduct. Yeah, we're only at 120 milliamps. So let's see if we can get some more into here. Filter hum is definitely there. Okay, we're getting conduction. It sounds like something just spit it out on us.
Because the property isn't worth what they thought it was worth. Because what they probably did is they probably went out and found a realtor who's part of that 80% that only makes 20% of the money that said,
Okay, I'm going to turn it off. So what did we learn? We learned the radio essentially works. We know that the filter capacitor is bad. We'll get that changed out. That's not a big deal. We're getting a lot of distortion on some other things. We could have a bad tube. We could have some bad resistors. So I think the next step of business will be to change out the filter capacitor and maybe go ahead and change out the audio coupling capacitor to make sure it's not driving the audio tube into overdrive, which could be what we're hearing there. So I've been looking for this 0.05, and this schematic doesn't show it, but that's a couplet. And I think there's a couplet. All of this is in a couplet network. So it's probably not bad. Okay, I got the schematic out of the writers, and the other pages of the writers for this radio. The second page, it shows the couplet, and it's a pretty simple one. It's got four capacitors in it, and these 4 capacitors are 17 is on the volume control. The one we're interested in is this one right here on the bottom, C20. C19 and C26 are here and here. I'm going to assume they're okay. I'm going to assume all 3 of these are okay for now. The one I'm mainly interested in is this one right here. And if I look at the way this is done, I think what I can do, I can leave this one connected so that that part of the network is still there. But what I can do is cut this lead off and just leave this old C20 hanging. Okay, I guess I'll cut it short, and then what I'll do is I'll just run a separate capacitor, probably a 0.0047, from here over to pin 5 of the 50C5. I'll just J-hook that into the lead. So let me get that change made. We're talking about this lead right here. I think what I can do is I can leave that one. So here's the couplet, and this is the one that comes up from pin 7 of the 12AV6. I'll leave that one, but what I can do is cut this one and then J-hook a capacitor from here over to this one. So basically bypass the one that's inside there and leapfrog it across, and then we'll see how that does. Whether I end up with that couplet still in there, or if I just recreate this and just stick it in separately, we'll see how it goes. But for right now, let's just see if this thing will even get to working. And then before too much longer, I'm going to go to the clock, because if the clock doesn't work, you know, the rest of this is really kind of a parts set. So anyway, but I'd like to see if it'll play. All right, let me get that done. I'll bring you back after I'm done. Okay, so we got the filter capacitor out of there. I don't know if that date code tells you guys anything. Doesn't really say anything to me. Anyway, it's out. You think it was original? I don't know. Okay, so this was 50 microfarads each, so I've got two 51 microfarads at 250 in there. What was this rated at? 150. Yeah, so I've got one here for the yellow lead, one down here for the red lead. So I'm going to separate it, and let's just see what we get. Okay, see how it sounds differently, if at all. Okay, voltage down, bring it up. No glow in the light bulbs, so I didn't short anything doing that. That's always good news. Let's do 75 volts, since we got a couple of new filter caps in there. And we'll see what we get here. $130 milliamps. Here it comes.
I think she'll. He hit the blank button.
Oh, man. Yeah,
wow.
That's the first time I've ever done that.
Show fat fingered the old 1988.
I wanted to, man.
Desk phone.
Go ahead, just let me handle the buttons from here. No, I'll handle it. It's one time. You all right? I don't come in there.
And again, unlikely that he's going to be replaced by somebody up left. He's vowing to fight on, by the way. He says that he is not going to resign. Again, according to the New York Times, his support continued to hemorrhage on Wednesday. That's the day after he suffered 2 shattering defections from his cabinet. More junior minister resigned. Johnson vowed to fight on, trying to affect government tax cuts he said would help millions of struggling Britons. In bathrooms across Westminster, lawmakers were meeting about ways to force Johnson out, possibly within days. Apologized again.
What you doing? Something's starting to go bad here, right?
Johnson's board. Several conservatives called on him to resign, including Gary Sandberg. A lawmaker from Birmingham was a ranking official on an influential committee of conservative backbenchers that control a future no-confidence vote. This suggests
So I
that
probably
votes may have
need
shifted from the
to
cabinet
clean
parties
the
requested, but
volume
lawmakers-
potentiometer, but it's not noisy.
The Prime Minister is in greater political peril than any other time in his tumultuous 3-year tenure in Downing Street. It turns out that
I just need to adjust the trimmer on the antenna some.
in a very short order.
I'm really waiting for is to see if the silver mica disease is going to start up.
Last week. We're gonna do best stuff for Friday. It's Wednesday. That's Friday.
No,
Okay, that's the bottom of the band.
Better. Peaches Hewley. He's getting better. And my favorite. And when I push it.
People don't like this hypocrisy very much, and unfortunately, lockdown advocates have been
Support.
Can you believe how good the speaker sounds?
Lodge, it's Twin Peaks. Eats drinks. Scenic views. Pena drives it pretty deep to center. At the wall, looking up. Early fireworks for the Astros. Welcome to that home run, Jerry Pena. This is Jerry Pena. Sports Sun 790 is your home for Astro baseball. Now, the drive from the Wingstop Traffic Center.
So notice I'm only going in at 75 volts. I don't know if I want to knock these egg cases off. That's probably what's holding the speaker together.
The 790 Traffic Center front.
That tells me where we are. 790. That's about right.
Still got one more segment to go. NASA says China soon wants to control the moon.
This is a hot radio, actually, considering, you know, inside my shop here, with just this little antenna back up against a metal plate here, at half the operating voltage. Well, nearly.
Correct answer.
all right, guys, this is it. As far as I'm concerned, I said it before, but I am more convinced every single day. This is the key issue. There are many issues. You look at the figures. Only 18% of the country think that
I think the thing to do now is switch our attention to the clock. I mean, yes, it has a couple of more wax capacitors that need to be changed. The tuning condenser needs to be cleaned. You wouldn't mind, you know, getting some of this stuff blown off, dead spiders and so forth. We can look for a new speaker cone because this one's trash. And but you know, get rid of the egg cases that are on it and all that good stuff. Clean it up. But basically, this radio works. So I think what we're going to do is park it for now. Good
Dạ
heavens.
rồi, xin chào anh nhé.
Nghe lùng bùng không?
I mean, I'm at 75
Em,
volts.
đúng là khi nào mà mình tới cái chuyện của mình.
All right, what I'm going to do is I'm going to let it play for a bit just to see if silver mica disease shows up. But then I'm going to be setting up to try to work on the clock and see what the clock looks like.
It only happens if you're involved, if you're engaged, if you're part of the solution, if you're prepared to fight for the truth.
Or to sing.
That's KC delivers more.com.
Okay, input. How is the hard drive already full? Jawan's Pilates studio.
1951. So this thing is
But leading and editing sessions.
59 years old this year.
Render failed. What I did.
And it looks like it's pretty much original. I don't know about the filter cap,
I need Indeed.
but the rest of it I think is.
Instantly connecting with quality candidates whose resumes on Indeed.
I mean, I see Sylvania tubes.
Earn up to $500 in sponsored job credits by conducting.
This one was okay. This was a realistic Lifetime, which most people tell me was truly garbage tubes. So this is not original. So we know people have been in here.
Successfully managed the roundabouts on May.
Okay, I'm gonna leave it playing for a while. Check on the clock, and I'll bring you back after I've let it run for a while.
Plan for your business. Do you want your business to be on?
Okay, it's been playing for quite some time. I didn't notice what time I left, but this is the time now, so maybe I can check it and edit and see how long it ran. So, no indication of silver mica disease, miraculously. It sounds good. Does it need an alignment? Maybe. If I touch this, the antenna gets stronger. But, I need to get the antenna as it normally would be positioned to the chassis before it's trimmed anyway. So, I mean, it's probably pretty good. So, before we go into the clock, just a few things. If I'm going to restore this for being a daily driver, I need to go in there and replace 1, 2, 3, 4 capacitors. 2 of them need to be replaced with safety capacitors. I'll do that not right now. Okay, I've got the next thing I want to do is I want to get onto the clock, because if the clock doesn't work, I really don't know what else I'm going to do with this project. So I don't need to put a lot more work into this chassis other than just knowing it works. If the clock doesn't work, I may just not do any more of the capacitors, put a note on it, maybe rob these capacitors back out and just leave a note on it as a chassis, that if somebody needs a capacitor or whatever, it'll work out okay. And I did count the windings on the antenna. If anybody needs to know about this antenna, through this portion right here, I counted 25 wires. Okay. I'll get a tape measure onto this so you can get an idea of what the dimensions are of it. I'll just go ahead and disconnect it. Okay, so you can see how the wraps go. So here to here I count 25 wires. So as you can see, there's another wire here between here and here. So it's like 26 wires between here and here, and 25 between here and here. And I'll get a tape measure on that. So the outside of the racetrack I get 9 1/4. On the inside of the racetrack I get about 7 3/4, thereabouts. The height of it, what do you get? About 4 inches on the outside and about 2 3/4 on the inside. So anyway, let me just kind of put this here. You can pause this later if you want to, and then like this. Okay, there you go. All right, I'm going to get into the clock.